hopefully you can see the title slide now. This is about a lecture course that Igor and Bill delivered last autumn. So what I'm doing by starting things off is merely setting the scene. So consider me to be the warm-up guy, and then Igor will take over in a few minutes to take things further. However, I couldn't resist just at the beginning of this, although it's nothing to do with what we've been doing in Manchester, just to give a view of something I came across at one point not too long ago. What were we thinking things would look like a few years ago? What was the view of the future from the 1960s? And as I say, I came across this. It's not exactly where we are now, but you can see, yes, we have what's presumably a corner of a room full of students interacting with the console in front of them. However, it seems to be more mechanically rather than electronically driven. However, some of the questions that would have been asked while setting this up were no doubt similar to, for example, the kind of questions that George was considering this morning. It seems obvious that one question that has been addressed when it comes to setting up what we see is, at what point are we going to give the students the feedback? It seems once they're committed to the answer and move on to the next question. Well, things have not proceeded in exactly this kind of manner, but I think it's quite instructive to take a look here. But instead, I just want to give an idea of the picture of where we were with respect to computerized assessment in Manchester as of maybe about 18 months ago, and how we got to that point. So going back maybe halfway to the 60s, yes, in the 1990s, there was computerized assessment use of complete packages where you got the package, the structure, you got the questions, and yes, for example, CAM was quite good, but it was a case of it was a case of using the questions that you have there. There was, of course, a desire to start authoring our own questions, and yes, throughout the 2000s, question mark for Windows and WebCT were good tools for this. WebCT, yes, it allowed us to use parameters. We used them for coursework tests, and we used them mainly for students taking maths courses as part of another degree course. We used them a lot for the service courses. But it was around 2007 that we were getting word that there was a new piece of assessment software in town, and that, of course, was the STACK system. So at Manchester, we have been using STACK since around 2008 and 8. There were a few of us using STACK for various pieces of assessment around that time. Since 2008, of course, the system has progressed tremendously. There have been several upgrades. Perhaps one of the most significant ones of those was around a couple of years ago that we were able to connect to STACK through Blackboard. And that was a tremendous jump forward. There were a few other jumps forward on the way, but this jump forward, for which I would acknowledge the work by my colleague Stuart Anderson, this meant that it was not necessary to have a particular session at the beginning of the semester where students would all create their accounts on the Moodle server that we were using. And it would also mean towards the end of the semester, when we were trying to get the numbers back to the Blackboard area for combination with other marks, it was not a case of having to do it on a one-by-one basis with students. Yes, about 60 to 70% of students were very cooperative in terms of giving us putting their number into the system, but obviously, when we had things going through Blackboard, it did make a tremendous difference there. So it continued that we were using Stack for coursework rather than exams. We were using it also for general practice. It wasn't the case of everything that the students used Stack for was giving them a mark. It's also worth saying that the great majority of things were unsupervised, but we did have a few cases where we would get the students into a room for a quiz. And also, yes, when they were first learning it, it seemed easiest to make announcements in a supervised session, but there's supervised in a different sense here. We did develop a few modes in which we would use it. I use the term here, practice and assessment modes, but to be honest, I'm still looking for the correct wording for this. Practice and assessment go close to what I mean here, but in a practice quiz, a particular assignment, there might be a practice quiz and an assessment quiz. Practice quiz, do as many times as a particular student wants. So not only are we assessing them, but of course, they're able to learn. We're providing feedback there, and they get immediate feedback. They can use this feedback in their next practice quiz, or when they feel ready, they can go to the assessment one. And for many quizzes, it was exactly the same question stems, although in one or two cases, and we did tell the students in advance about this, there would be a couple of questions which were new rather than just making use of the same question stems with different parameters. The assessment quiz would just have a single attempt, and we had different policies for different courses on the feedback there. And then the mark in many cases, not all, in many cases, it was a weighted mean of the best of the practice attempts and their single assessment attempt. So yes, it was a case of drumming home to the students that yes, the best practice quiz did actually count. There were a few slightly different modes that we would have there. There was one particular course, for example, assignments each week, and as long as students got more than a particular threshold, set at 60%, they got the credit for that particular quiz, and that credit would assemble in order to give them a mark at the end of the quiz. One place where it proved extremely useful was what we called the diagnostic follow-up. Now, the students would take a diagnostic exercise. Okay, previously we called it the diagnostic test when they arrived. This was a multiple choice thing done by various means, sometimes originally on bits of paper, sometimes on Blackboard and so on. But following this diagnostic exercise, each student gets an individualized program of work involving a couple of sections. And yes, there would be reading and other resources there, but also practice and assessment quizzes. So this setup whereby different students were asked to do different questions, this was something that was not particularly easy to work by hand, but using an automated system such as Stack did make things really, really much easier there. So that takes us up to just a year or two back. The situation in around 2019 to 2020, yes, with extensive experience of running coursework and general practice through Stack. Stack was now linked with Blackboard, and I'm really glad that this development happened at the time that it did and wasn't waiting for us to deal with now alongside various other things. It's great to have this development occurring. We had set up various means to acquaint students with the system before they had any assessment, starting off with real practice ones, quizzes that just test what it is that they're inputting, showing them that they can use the system. We had various things there. But of course, what we did not have was any of the end of semester exams. That had not happened until more recently. So hopefully I've now set the scene, and I can hand over to Igor to describe the course unit that he and Bill carried out last autumn.
Right, I'm about to share. Can you see it? Yeah.
Yes.
Right. Yeah. So I just continue. So Colin really made a brilliant introduction to what we're dealing with in Manchester, and I will tell you slightly more on the technical and the pedagogical side of our particular course unit. Well, first I also have to acknowledge that we had absolutely unparalleled support from the Maths Teaching and Learning Office, particularly this year, and a learning team. And of course, it's all made possible by the Chris Sanguine and Stack user group who made this tool available to us. Briefly, the structure of what I'm going to talk through, I'll tell you what was the structure of our course unit this year compared to last year, what was the exam and how we organized it, and then I will move to talk about technical and pedagogical aspects of that, and learning outcomes and the outlook. So that is a relatively advanced course, so certainly the most advanced course which the EEE, which is the electrical engineering students learn. So it's the final piece of mathematics. And it has two course unit leaders. So I was covering first two parts, and Bill Leinhardt the last part. And it is a large cohort and extremely diverse background. So some students are carrying on from the year one, but some are direct entry students. So they have very different level of training and a very different background. Well, I wouldn't dwell too much on the difference, but the main difference that it's been a relatively traditional structure last year, and apart from the STAG tests, which we used for the practice and the assessed coursework, all the rest was very traditional. So this year, we delivered the entire course online, including all the tutorials, all the lectures, and all the assessments. So there was no physical contact hours, and certainly that made a difference. And we wanted to assess the assessment, so how much that affected the students and what we can learn. So the exam. Again, I wouldn't talk too long about this tag, so I think many of you are familiar with it, but I'll just highlight some of the features which are important to us. So first of all, it's robust randomization. So we want to be able to make sure that we have a quality control questions, but at the same time random enough for a large cohort. And importantly, it allows to effectively replicate and even enhance what's traditionally done by doing carry through errors and doing consistent marking. And of course, the most valuable part of it for many students is the feedback. So it's an instant feedback for coursework, but it's deferred feedback for the exam. But again, that's a choice. And that can be mixed, and it was mixed in our particular exam paper with a semi-automatic marking. So the students were asked to upload a short sketch, which is a part of Moodle question, easily mixed with tag, and also to enter unassessed, not automatically assessed textual comment alongside the automatically marked numerical entry. So that is flexibility. Of course, that means that there will be at least aspect of the question marked manually, but compared to the amount of work, it's relatively minor. And it certainly allows a bit more insight into what actually students learn if we cannot assess it using the standard techniques in Stack. And also it allows a quite advanced multi-part questions. So for example, you can see here an example of the question where we not only ask for the final answers, but we also ask for the intermediate word solutions, so that we actually can see more information to assess the learning outcomes. And more importantly, because we're using this computer algebra system behind Stack Maxima, we can do carry through errors. So if student makes a mistake at a particular stage, we can still carry through and assess if the method is applied correctly. So that, I think, was quite well received generally, but it doesn't come without technical challenges, because as advanced system as Stack is, it still relies on the computer algebra system, and in our particular course, we needed to deal with the piecewise continuous functions, say for Laplace transforms, and it's not part of standard maxima, so we needed to enhance it. And for that purpose, because it is open source system, both the Stack and the maxima, it is possible to find and to use the benefit of community and to effectively use the custom functions inside Stack to enhance the capability. And likewise, for example, if we want to look at the symbolic exponents and to analyze the student expression, to parse them, we can also use a benefit of maxima. And I think Chris Sanguin in one of the meetings mentioned that it's increasingly becoming useful and possibly timely to get the database of Stack user group experience, which small tips and a piece of code can be shared across different universities. But what I really want to focus more is about pedagogical challenges. So by the way, the pieces of code I showed, they're available on the Moodle. So if you're interested and the benefit of time, I wouldn't spend more on it, but please ask me questions or look at it. The primary challenge I perceive here is the digital literacy, and it's certainly not at all as uniform as I would expect across the student cohort, and particularly student understanding of what computer-based marking can or cannot do. Certainly, and it requires some attention and managing expectations, particularly when students are experienced with using other marking systems like Blackboard, which are not as maths-oriented or not as sophisticated. They're often expected to be 100 to 0% for the correct answer or incorrect answer. So they not necessarily appreciate the flexibility and the robustness of assessment. And also, of course, because it's and these aspects also been raised quite well in George Kinner talk, if you've seen it this morning, is how students interact with the online or computerized assessment systems. So there can be quite unusual syntax, which also in some sense could be thought of the understanding and their level of proficiency with particular mathematical domain. For example, how they enter functions, do they understand what function is? And likewise, if we deal with the multi-part questions, it gives us flexibility to assess their method, even if they made a slip. But if they don't enter something in a multi-part question or ignore a validation error, then it becomes particularly a problem. And that makes me think, for example, is can we think of the accuracy of the input is actually a learning outcome? Because ultimately students are prepared to be the industry leaders of the future, certainly the engineering students we teach, and they needed to be prepared for the workforce environment. And they certainly needed to make sure that there's a minimum standard they should reach to enter correct mathematics, even if it's in terms of spreadsheets or in Excel, for example. And actually some students do appreciate that, and feedback I received from one student, for example, saying that they actually do like the idea that they can train themselves in getting an accurate, well, they call output, but it actually input of the notation. And that's certainly something which the system like Stack helps students to appreciate and develop the skill in. Other aspect, of course, is its authenticity, and there are Wolfram Alpha-like engines and electronic systems like Stack, and they make it relatively easy to copy pieces of algebra from one thing to another, even if it's randomized. But on the other hand, if we ask intermediate steps, it makes less of a problem. And my experience, again, and some of my colleagues, shows that it's certainly of much less issue in Stack-like systems compared to the traditional take-home assessments. But other unexpected aspect was time management. Because it's a timed exam, but it's effectively a time test which with no external management, so students self-manage themselves. We had an instance that students start really late and don't really have any time to do the exam, or the student leave very early. And you can see, for example, here in a relatively, it's of course it's a sample of one exam of one particular cohort, but you can still see that there's some evidence of trend where duration is a correlator of the achievement. So some students who leave really early, they might underachieve because they're just frustrated and not necessarily prepared to persevere. And that might not happen in a real examination. They're not allowed to leave, say, after 20 minutes. So they still have to stay. And likewise, students who leave a little bit early, they do not really spend time validating and checking their answers. So potentially considering implementation of more traditional time management experience and restricting leaving or entering the exam might benefit the students. And briefly about understanding the outcomes. Well, because it's such a data-rich system, we have quite an amount of data to try to get some insights into what students learn and how their result across the cohort in different assessments correlate with the timeline of this course unit. Well, first of all, I want to say that we was really happy that it was quite robust and for the examination purposes assessment, and indeed it saved us quite a bit of time. So taking aside the time for designing the system, this course was traditionally marked by about 6 markers over a week period. With the stack system, it was marked in a matter of days, just taking into account quality control, more or less, and some small amount of manual marking of the sketch and the comment. So that certainly is a very positive outcome. But what we also can look is we can compare the statistics across this year and last year. And what is evident, without going into details, and also this is rather preliminary, so somewhat a speculative statement, so that's a disclaimer, is we saw more evidence last year that it was important for students to start engaging with the practice tests early in stack for them to get high outcomes in terms of final examination mark. While this year, the most strong correlating factor was the final piece of assessment before the exam, which showed that it's more the sustained engagement with the course material which helped them to stay on track, which partially explained that there was much more self-managing and kind of pacing their own education this year. But what I would like to summarize is that Stack really is a robust environment for both developing proficiency and assessing the outcomes, but the digital literacy is a barrier, and the expectation of students needs to be managed, and they need to be educated more in how to use these systems and what to expect from them. And also it gives us a new tool to try to see and assess what helps students most and what we can then introduce to or change to help them achieve most and take most of the course. And of course, there's a cost associated with designing these assessments, but it really pays off for large classes. And last but not least, Colin gave an insight in kind of history of assessment, but I would like to give a parallel with the industrial revolutions. And I mentioned the students, particularly in this cohort, are going to be engineers and electronic engineers. And you might have heard of industry revolutions, and the most recent one where you have data-rich environments, see here. And I would venture that similar can be thought for education. And it's quite lags behind somewhat from the postal correspondent courses to the Open University innovations and more recent massive online courses. And they're all slightly kind of behind if you compare to the corresponding stages for industry development. And so perhaps with the help of tools like Stack and others, we can revisit how we assess and also teach to catch up with the current needs for industry. Thank you very much.
Thank you both, Colin and Igor, for a very interesting talk. So I think we should show our appreciation. Thank you. Questions? Thank you, Christian, for reminding us that questions are best placed in the Moodle forum, not in the chat, so that they remain and that we can possibly answer them after the session. There is one question there, Igor, already. Did you see any difference between engineering students and mathematics students in terms of their syntax errors?
Well, I can only talk about engineering students because this particular course was targeted at engineering students, but maybe Colin can comment on other aspects.
The majority, of course, of what I have done has been with students who are not math students. I can't say I found a massive amount of difference with the syntax there. I suppose a lot of it is to do with, yes, what do we tell them at the beginning? We do give them various quizzes on just how they would enter particular answers. So this is in their first year. But yes, I can see the question that Christian's asked, confusing the multiplication and the function application. Yes, this is certainly something that we find is often happening, and at the back of it, we do worry, have some of them not fully understood just what a function actually is. And of course, sometimes, yes, we see this, some of them might write sine times x. That is the kind of thing that we're able to get them over quite quickly in the first year. But the unit step function, for such a simple function that it is, it's a case of, it does bring with it, both in the traditional on paper assessment and with entry into stack, it is a function that seems to cause more difficulty than you would imagine for such a simple function. So veered a little bit away from the one about do the engineers have more trouble? I haven't noticed a great deal of difference between the two. I acknowledge that both groups do have trouble there.
Yeah. Thanks, Colin. We have another question. In the example you showed, you asked intermediate answers and gave partial credit for the intermediate answers. How do you test that the learning goals, when the learning goal is that the student should know what steps to take?
Yeah, so that was the part of the purpose of this multi-part question, that we test the method and not just a perfect solution. So in a sense, that allowed us to make sure that even if they made a slip, thanks to stack, we can still assess if they know the method.
Right, but you have broken down the problem into the steps already, haven't you?
Yes.
And I think,
there's still small steps to take. So they still needed to know enough steps to jump from stage to stage. So
okay, I think the question is driving it. How do you get the student to do solve the whole problem independently?
Well, we had other questions which effectively required them to do more of that. But I think the problem is that we really wanted to kind of cater for students who are not necessarily as strong and wouldn't be able to really get with that, because since we are assessing an answer, and if it's really wrong, then effectively we'll get no credit for that question at all. So in a sense, if with traditional paper, we might look and see evidence of the answer, but if we don't ask for it, then we wouldn't be able to assess it.
Yeah, it's a classic dilemma. So yes,
probably the same dilemma that you have on a bit of paper, but in the traditional type of assessment.
Yeah. Well, thank you, Colin. Thank you, Igor, for a very interesting talk. And